Hey guys, and welcome to Functional Print Friday. So on the bench this week is a can, and in that can is some ground coffee. Because what I want to do this week is design and 3D print a scoop to make the perfect cup of coffee. Now, admittedly, that probably sounds pretty crazy, so I feel like I should probably give you some background on why I would even consider doing that, and how I make a decision as to what things make sense to design and print. So a couple of years ago, I was making coffee in a Keurig K-Cup coffee maker, like I imagine the majority of people probably do, since those things are just crazy popular now. And I was putting milk and sugar in that coffee, and I have 2 to 3 coffees a day. And occasionally I'd go out places that had really good coffee, like a coffee shop that's local to us in a farmer's market, and a couple other places, and the coffee was so good I wasn't putting anything in it. I was just drinking it black. And one day I thought to myself, why the heck am I drinking all this milk and sugar if what I really want is just good coffee? So I started buying whole beans, grinding just a few days at a time worth of coffee, and then making my own coffee with a little pour over setup. Now, it doesn't really matter how you're actually making your coffee, but if you're starting from whole beans and you're grinding just a few days worth of coffee like I am, you probably have a can that's not too dissimilar from this one that has some ground coffee in it. And you can see there's not a ton of ground coffee in here. I tend to grind probably about a day and a half worth of coffee at a time. I find any longer than that, the taste just starts to degrade, and I'd rather start over with fresh ground coffee again. And that probably brings me to my second point here of how in the heck I decided that it was worthwhile making my own coffee scoop, because I can already hear you guys down in the comments. This sounds insane for so many reasons. But let me walk you through the primary things that I look at when I'm considering whether it's worth designing and 3D printing something. Probably the biggest one is the severity of the problem. And I'll admit, this is not a super severe problem. I'll get to the problem in a minute, but it's not a super severe problem. It's not preventing me from making coffee. The other one is the level of effort. How long is it going to take to likely design, print, and iterate this? And the last one is frequency of use. And that's where this one wins out, because I'm making coffee 2-3 times a day. So this thing gets used all of the time, every day, all the time. In fact, I usually have 3 cups of coffee. So you could figure that I'm using this almost 1,000 times a year. And frequency of use is something that's important to consider when you're solving a problem. Now, what is that problem? All right, well, 2 things. So this is just a generic sized coffee scoop. It came with something, but you notice the shape of the coffee scoop. It's round, but if we look at the edge of the bottom of the can, it's basically square. So when I go to scoop the coffee out, see what happens here. It leaves behind all this coffee. Now, that's not a big deal when I have this much coffee in here. I can still get a whole scoop of coffee, knock this off, and get another whole scoop of coffee. And that's about what I use. I use kind of like one heaping scoop and then one sort of level scoop until, I don't know, it just sort of looks right to my eye. The problem is when I'm down sort of lower in the can, where there's enough in this to make a cup of coffee, but I can't get it out. At least I can't get it out in a fashion that I can measure it. Sometimes I'll end up kind of trying to get it with a scoop and then trying to just dump it out. And I end up spilling it on the counter. And the second problem is consistency. Because I'm measuring with sort of it's like kind of about that much and then maybe kind of about like that much. It's never really consistent. So I would say like 1 out of 3 cups of coffee I make myself is like perfect. It's dead on. And the other ones are like, it's okay. It's a good cup of coffee. It's not perfect. So what I'd like to solve, because again, I'm using this 3 times a day, so frequency of use, is a scoop that gets all of the coffee out of the bottom of this little can, and a coffee scoop that is a lot easier to measure the amount of coffee that I need for 1 cup of coffee. So that's my design goals on this. I want something that scoops all the way down into the corner of the can, and either that is dead on for using 2 scoops, like two perfectly level scoops is exactly the right amount, or 1 scoop, and that would be the ideal scenario, is the correct amount of coffee. So the other 2 design considerations I want to keep in mind are, when we're done, this thing should fit in the can, right? We should be able to throw it back in the can, close the lid, put it in the cabinet. I don't want to chase around another loose object in the cabinet. And this thing should be comfortable and easy to use. Like, we could come up with a solution that gets all of that coffee out of the corner of the can and measures the correct amount, but it's just impractical to use, either because you have to hold it in a super weird position, or it just otherwise sucks in actual daily use. And I should mention, by the way, the reason I have a problem with this not being able to get all the coffee out of the can is rather than try and dump it out of this can, which almost always results in a spill, I end up just grinding more coffee and then mixing fresh ground coffee with, what at this point is approaching stale ground coffee, which I really don't want to do. Whenever I grind coffee, I want to start with a can of completely fresh ground coffee for that day and a half that I'm going to use it. So, all right, let me fire up SketchUp and start just designing something. All right, and here is the initial design that I came up with for this. And I tried to keep it fairly simple. I mean, at the end of the day, this is just a coffee scoop. So, we've got a standard coffee scoop sort of on this side here where it's a curved shape. We've got the handle. I went ahead and put the word coffee on there just to be cute. And on this side, instead of having the other half of a round scoop, we have these two faces that are 45 degrees to each other, as such that this one should ride on the bottom of the can and this one should ride on the side of the can as we scoop around the can. So I think the next obvious thing to do is to just go ahead and get this guy printed out so I can hold it in my hand and actually try it in the can. So I'll see you guys in what'll be seconds for you and an hour or two for me. All right, and here is our first test print, and it came out quite clean. We did have supports all the way underneath this handle, so this is kind of a rough surface down here, but they broke off pretty nice. So let's give it a try. All right. Okay, so first problem I'm seeing is it's awkward to get in there because it really has to seat against, it's seating against this face and this face in the can, which means you've got to seat it like this first and then go around the can, which ends up, I don't know if it's kind of hard to show. The way, at least where the handle is, it's really hard to swing it around in the can. It is doing a really good job getting into the corner though. I don't know if the video is picking that up. So we solved that part. I think this is holding more coffee than that white scoop. I don't think it's enough. It doesn't look like, it's not, it's going to need to be bigger than this. But it's very awkward to use. It's not natural to get it into this position. I think because the arc that you're moving with the scoop just doesn't line up with a comfortable hand position. I think what we need to do is maybe slope the front of this so that you can kind of use it at an angle, like come in at an angle and still chase the side of that. Because if we come in at an angle with this one, it's still going to leave coffee behind. It's going to leave it sort of behind in a different way than that white scoop, but that's not really working. So, all right, let me slope this back like this and see where that gets us. I might also try moving the handle to one side or the other as well and just see how that feels. All right, I couldn't decide which way the handle should go. I was just having a hard time wrapping my head around which was going to be more comfortable to hold, so I ended up making two, and I just flipped it in CAD. That's why coffee is backwards on this one. I just flipped it on the axis. So on this one, the handle is offset to this side. On this one, the handle is offset down here, and you can see that I sloped the front. So let's see how this works. All right, I've made it worse. I don't think it's the slope, though. I think it's the handle position. So this one's definitely no good. Yeah, okay, so that's where I would want the handle. That makes sense. I can now set this in. Yeah, that slope hasn't really helped us at all, though. I think I wasn't really thinking that through, because where the slope is, it doesn't actually allow us to swing it back at all. This face and this face still have to touch against the sides of the can, so we're not getting any benefit from this slope at all, other than, I guess, the coffee kind of falling back and filling the scoop. but we've also significantly reduced the volume of the scoop. Yeah, so this is actually easier to use because of the handle position, but the slope in it hasn't made it any easier to use at all. I'm almost wondering if we should just go back to this design, but with the handle offset. Let me think about that for a bit. If there is a, you know what, I wonder if we, so this slope here isn't doing us any good, but what if the slope was onto this side? So it started, so instead of the slope starting at the center point and sweeping back, what if the slope started at this center point and just swept back in this direction? I think that would let us come in at an attack angle that made more sense in the can. Yeah, let me think about that. I'll bring you guys back. All right, this is what I came up with. So I kept the handle offset like the one that we knew was comfortable to use based on our previous test, but I added that slope, just like I was talking about, from this face down. So in theory, this one should allow us to come in at a much more comfortable angle. Oh yeah. Yeah, that's actually, yeah, that works really well. All right, so it's a little hard to see with the coffee in here, but you can come in at an angle with this guy. Basically, that is the, if I set it in position, there we go. That's the angle that you're starting at. The handle's in a comfortable position, and then you're just sweeping around the can, and it gets all the way into the corner, and it's easy to fill up that scoop. Now, the problem with this is, again, we have reduced the volume of the scoop versus our initial prototype. I don't know how much reduced it is in comparison to the original scoop. Let's see if we can estimate that. So that's about one of the original scoops. Yeah, it actually holds less than the original scoop now. So size might be an issue. I don't know that we're going to be able to make this design big enough to get the right amount of coffee and still have it be practical to use. So we might have to adjust the design as such that two of these, like perfectly level, is maybe the right amount of coffee. But I don't even know what the right amount of coffee is. I mean, I do. I can scoop what looks like the right amount of coffee with this guy into a filter and then measure it. But how are we going to measure it? I actually have an idea for that. Let me try something and I'll bring you guys back. Okay, and here's what I came up with. So what I did was I drew a cylinder of a specific dimension, and then I printed that in transparent PLA so that I can see the amount of coffee in here. And then I added to this cylinder the exact amount of ground coffee for a perfect cup of coffee for me. Now, I realize that might not be the amount of coffee for you, but that's okay, don't worry. I'm gonna show you how to use this to measure that, and then how to also size your scoop to be the exact correct size for you. So I know the dimensions of this cylinder, so if I know how high into this the coffee is, I can calculate the volume of coffee in here. So let me grab my digital calipers and just measure how tall the amount of coffee is in here. And it's about 38 millimeters. It varies a little bit as I rotate it around, but if I have it pretty much right at 38, I would say that we are at about the right spot. So, all right, let me take it back to the computer and I'll show you now, based on that information, how we use this and that measurement to know exactly what volume of coffee we have in here. Okay, and here is my design for that clear PLA test cylinder that you saw me measuring the coffee in. And I will include the STL for this in the downloads for today's video, so you guys can print one of these out and measure the correct amount of coffee for you as well. And very simple design. It's just a 0.8 millimeter wall over here with a 1 millimeter bottom. I'd size this to be 0.8, so we got exactly 2 line widths with a 0.4 millimeter nozzle. Now, we need to calculate the volume of this, and more importantly, we need to calculate the volume of this, or the volume of coffee in here filled to that known height. Now, there's a number of different ways we could calculate that volume. We could simply do the math, but I tend to be a very visual person, and I like to do things in a visual fashion if I can, because I just find it reduces the chance of making an error in those mathematical calculations. And you should be able to get your CAD software to do this math for you in a visual way. So if I take this and I group it up in SketchUp, it's actually going to show me what the volume of this solid object is, 10,465 millimeters cubed. Now, This is misleading because that's not the volume inside this cup. That's the volume of the solid object. So the space inside the walls of this object and the space inside the thickness of the bottom. That's not the value that we want. So what we need to do is get down to really just the object that we're actually, occupying with coffee. So in that case, if we take just the inner wall and we close this guy off and we group it back up, now we're getting the actual volume of the inside of the cylinder, and that is 126,586 millimeters cubed. Now, it's still not the correct volume because we didn't fill this whole container with coffee, right? So all we really need to do now is just bring this down to the correct height of the coffee that we measured inside, and I have already done that over here. And if we take this guy and we group it up, we can see that the volume that we're shooting for is 68,797 millimeters cubed, roughly, right? So that's, now we know. Now that's the correct, for me, that is the correct volume of coffee for a cup of coffee. It's going to be different for you, but you can use the same methodology to figure it out, what that is for you. So, okay, Rich, I hear you, but now how do we get to figuring out how we scale this scoop to hold the correct amount of coffee? Well, let's figure out what the volume is now. We can do the exact same thing with the scoop that we did with the cylinder, and that's already what I've done ahead of time here. I just took out the inner liner, I guess you could say, of this, and then put a lid on it. So here, I'll explode this, pop the top off so you can understand what I'm talking about here. This represents, I copied and pasted this and then just took off everything that wasn't sort of the inside skin of our measuring scoop here. So if we take that and then we go ahead and close it up. So again, we have a solid object because we need it to be a solid object to measure. And I don't even know how we'd start with the math of trying to figure out what the volume of that was. That would be, I'm sure you could do it. The formula would probably take up the entire screen. But SketchUp, again, is going to make it super easy, and so should the CAD software that you're using. Now, if I take this and I group it up, look at that. Magically, within, what, a tenth of a second, it's calculated the volume for us, and that volume is 33,621 millimeters cubed. So not big enough. I think we were, what was this one again? Yeah, roughly 69,000 millimeters cubed. This isn't even half that. It's close. It's close to half, but it's not even half. So how do we figure out now how we go from this to the correct scale? Well, we can just use a multiplication factor, and I've already done the math on that ahead of time, and I know that if we take this and we scale it by a factor of 1.269, because remember, volume doesn't scale in a linear fashion. So if we scaled this, well, you know what? Just for the heck of it, let's scale this 2 times its original size. Wow. It is now 268,000, almost 269,000 millimeters cubed. And again, we are targeting, roughly 69,000. So it is way, way bigger than we need. And also, I don't think this thing would fit in the can anymore. But fortunately, that's not how much we need to scale it. We need to scale it by a factor of 1.269. And that'll get us close. It's not going to be perfect, but it's going to get us close. Now look at that. We are just under 69,000, 68,707. And our target was 68,797. So we're only missing 97 millimeters cubed, which is not going to make a big difference. And I don't want to go out any more decimal points in that calculation. So we could take that, and now I'll duplicate our scoop. And if we take our scoop and we do the exact same thing, we scale it by a factor of 1.269. There we go. Now our scoop, when we print this guy out, and you can see the scale comparison to this one, the volume of this is going to match exactly the volume of coffee that we measured in our test cylinder. So, all right, let's go print one out in this size and see if it's usable. All right, and here is our scoop that has been scaled to hopefully give us the exact correct amount of coffee. And it's actually not crazy big. I was a little worried that it was going to be too big. I don't think it is. If we compare it to our original one, I mean, it's definitely bigger, but I don't think it's going to be too big to use. Let's try it. Nope, that's actually pretty easy to use. In fact, I think it might be easier to use this one than the smaller scoop. One thing I want to try too is seeing if we can take this coffee that we previously measured and dump it into here and just see how that looks. So I'll try and do this without spilling any. Hopefully you guys can see that. It is really, really close. It's a little bit over full, and I think that's probably just because the coffee settled in that cylinder that I made as I tapped it a little bit on the desk to get an even reading, but this is really, really close. There is no more than maybe like a 5% difference in volume, if I had to guess. All right, I'm really making a mess here, but I gotta tell you, the shop smells amazing right now. All right, guys, and here is our finished part with the color in the lettering on the handle. And it came out really nice, but I will say it took 3 times as long to print this with the second color in the handle than it did to just print this one in a single color. So keep that in mind when you're doing your design and prototype work. Don't add any of your cosmetic stuff in until the very end. There's no reason to take all the extra time and put all the extra wear and tear on your equipment for the color changes, or if you're doing them manually, the extra time and effort involved in those color changes, or even just other cosmetic features until you have everything else with your design down and ready to go. The one problem I was running into with this is actually the second go. I stopped the first one mid-print because when I peeked in on it, I noticed that there was some poor surface finish here on this overhang. In fact, it's actually a little bit thinner on this edge as well. And this was oriented on the bed like this. So if we're looking in, this would be the front of the printer up here, if you're familiar with the Bamboo Studio printers. The part cooling fan, the auxiliary part cooling fan is over here on this side. And I thought, I wonder if I rotate this part around and have better cooling on this overhang if the performance is going to improve. I've encountered that before, particularly with PETG parts, where if I print them in an orientation where I have an overhang away from the auxiliary part cooling fan, it fails. Like, it's not even close to a good print, but by rotating it around or getting it even closer to that aux part cooling fan, I'll get success. Well, with this one, it didn't really seem to make any difference at all. I rotated it around so that that overhang was right into the fan. And yeah, I can't see any difference between these two and that overhang. It's perfectly usable, and I'm gonna use this one for coffee in probably about 10 minutes when I finish shooting this video. But I may take another run at this with just a row of tree supports along the edge here. I notice when it's printing with that overhang, even with the cooling, it springs up and down a little bit, which is why you get that poor surface finish like that. If you've ever watched your overhang prints while they're actually going, even though there's something there to attach the material to, because it springs downward as the extruder comes across there, you just don't get good solid layer adhesion like you do in other areas. So I might actually try that with some manual supports in place. Now the last thing I want to touch on is the elephant in the room of this being PLA, a 3D printed PLA part, and I'm using it with something that I'm going to consume, in this case, coffee. And generally speaking, 3D prints and food or beverage just don't mix. And in fact, it's really kind of just about meme status at this point. Anytime you see anybody post anything, even remotely related to food that is a 3D print, everyone's in all caps down in the comments saying, not a good idea to use 3D printed parts with food. Now, while I do generally agree with that rule, I think there are some intelligent exceptions. First exception being single-use items. For example, like cookie cutters. If you're going to print something and use it as a cookie cutter, yeah, you're never going to get that clean again. And there's no sterilization of it that is not going to ruin the part, that is going to make it safe to use again in the future. But just throw it out when you're done. It's a cookie cutter. It costs you like 20 cents to print. When you need it again next year or in a couple of months, just 3D print another one. In this case, coffee actually has antibacterial properties. So the likelihood of any bacteria actually living on this guy and remaining there once this guy is kind of coated up with some coffee and oils out of the coffee is pretty low. But I'll probably still swap this out maybe a couple times a year. And I'm also exposing these, exposing what I'm scooping in here to very hot water in the process of brewing the coffee. Another thing that occurred to me is, especially since we did that car part in ABS last week, I wonder if I could print this in ABS plastic and then smooth it with acetone. If you're not familiar with that, acetone will dissolve ABS plastic. So if you print something in ABS and you put it in a container and expose it to acetone vapors, basically the part sort of just almost sort of melts together, and you lose some of the fine features of it, but there's really no fine features here to lose. And it should make it essentially like one solid part that would then actually be washable for reuse. So I might explore that, and if I do that, I'll probably mention it in a future video, but for now, I'm going to be using this guy to make my daily cup of coffee, and I am not worried. All that said, I'd love to hear from you guys down in the comments what your thoughts are on 3D printing and contact with things that we're either going to eat or drink. Not only just with this particular print, but also just sort of, in general. What are some examples of things that you think is just fine for 3D printing and food use, and things that you just would never do? And feel free to let me know. Am I crazy for using this PLA coffee scoop? Am I going to be dead next week? Let me know. All right, we've got some unfinished business. We've got to give away this filament dryer box as promised in last week's video. So let's go up and take a look at the comments on last week's video. All right, so I said last week that the filament dryer would be given away to the person that gets the most likes on their comment on last week's video. And I should also mention that I am recording this segment right now on Thursday. It's about 9 p.m. Eastern time on Thursday, the day before you guys are watching this video. So if the comment section looks any different, right now as you guys are watching the video versus what you see on my screenshot here, that's why, because 24 more hours have passed before you guys are watching today's video. But that's plenty of time, I think, for folks to get their comments in and to collect those likes on the comments. And kind of funny, there's 123 comments for last week's video, 1, 2, 3. And I think we can sort this by, see, if we sort it by top comments, what does that do? It appears to do kind of a combination of the most upvoted, but also the most recent, I think. Yeah, because this one's got 30, but the one at the top has 4. Not entirely sure I understand how they're sorting it, but I'll just give this a quick scroll through and see if I see anybody that has any more than 30 upvotes. All right, I've been through all 123 comments on last week's video, and the winner by a pretty wide margin is the FEMO 4505 with 30 upvotes on their comment. Congratulations, you are the winner of the Airy One filament dryer. So sit tight for a few minutes and I'll tell you how to contact me so we can arrange getting that shipped out to you. But before that, I just want to say thank you to everyone that watches these videos, whether you're subscribed or not. I really appreciate, you taking the time to watch these. It's really an outlet for me to be able to share this stuff with you guys. I've always really enjoyed designing stuff, printing out and just solving problems like this. And it brings me a lot of joy, honestly, every week to be able to share these with you guys. And if you remember, last week when I talked about this giveaway, we were celebrating 3,000 subscribers to the channel. And somehow in like the last 10 days, the channel is now over 4,000 subscribers. So thank you guys so much. For just coming and checking these videos out. I really appreciate it, and I really appreciate all the likes and subscribes really just in the last 10 days. And welcome to all the new subscribers to the channel. I hope you guys keep coming back and enjoy a lot of the content here. So all right, so how do you contact me? All right, and the FEMO 4505, what I want you to do is come over to my website, fpfdesigns.com, scroll all the way down to the bottom, hit Contact FPF. Go ahead and just fill this out. This will come over to my email, and we'll just figure out a way to verify that you are you and it's not just somebody else filling out the form. I'll probably have you add something to your comment or something like that. And I'll arrange to get this shipped out to you. Guys, as always, thanks for hanging out in the shop with me for this week's video. And if this is by chance your first time here on the channel, I do a new video like this every single Friday. It's always a functional print. We don't do any multicolored, trinkets just for the heck of it. It's always something that repairs something, adds functionality to something, or is just a totally brand new from scratch design. If that sounds cool to you, if you're into the engineering side of things like that, hit that subscribe button. And guys, if you do, I'll see you next Friday.